Hi, class. So today we're going to learn our first strategy for adding integers, which is what I find a lot of students like more than the other strategy, which is a number line, because it's more relatable, I think, and it's a little bit more fun to actually choose your counters. So we'll start with this one. A lot of students find it easier as well. So, what is an integer counter? That's our first question. Well, an integer counter is a symbol that represents an integer. Now, you could use a real life manipulative, like, for instance, some people give like little circles. One of the circles is red, one of the circles is green, right? And you can actually physically move and manipulate the circles to help you as your counters. Well, I actually have those as well. However, with the pandemic going on right now, and they're not always easily available to have those counters, I'm going to teach you a strategy where you can use no matter where, no matter any time. And that is to choose your own symbol that you physically draw. So, a perfect example could be positives are a plus symbol because we often recognize positives with plus, right? Negatives could be a minus symbol. So those are one of our options. A positive is a plus, a negative is a minus. Now, I've even seen kids do this. Positives is a heart. Negatives is a frown face. It doesn't matter what your symbol is as long as you label it. See, I put positives, colon, plus sign. That is telling me as your teacher that your positives are pluses and your negatives are minus signs, or that your positives are hearts and your negatives are frown faces. It doesn't matter as long as you specify which is which. Another option for symbols is colors. So what people do is they do, well, positives are going to be green. And I'm just going to do green dots for my positives. And negatives, are going to be red dots. So they use different colors to represent the positives and negatives. Again, it doesn't have to be green and red. Those are the most common because positives usually associated with go and negatives stop. But whatever you do, you just have to specify which is which. These are the most common two that I see up at the top here: the plus and minus, the green and red. And if you were in an assessment, you can always bring markers to help you if you want to use the color method, right? Markers, crayons, colored pencils, maybe even pens for certain parts of your assessment in order to get that different color combination. Totally fine. If that's not an option for you, then we go to symbols, right? So you have everything you need to now move forward with integer counters. So what do we do? How do we actually implement integer counters? Well, you have a series of steps. It's always most important. I'm going to highlight our steps because we always, in math, it's just a series of steps that we repeat no matter how hard the problem gets. So we outline the steps first, then we apply them and see how they work. So step one, we kind of already did it, but you have to choose your counters. One to represent positives, and one to represent negatives. Because remember, integers are whole numbers and their opposites. So we have to have a positive integer counter and a negative integer counter. Okay. So once we do that, then what we do is we look at the first number in our expression, or at the first integer to have better vocabulary in our expression, and model it in a row using our counters. So you look at the first integer in our expression. I missed the word first, which is very important. The first integer in our expression, and model it in a row using our counters. Well, after we do the first integer, guess what? We have to do the second integer. So now we look at our second integer, in our expression, and model it in a row underneath the first row using our counters. So in math, it's really, really important to be neat. So I'm going to show you that you make a first integer a first row with counters. Then right underneath, we align them almost perfectly to make a second row that represents our second integer. Now, our final step, or our second to last step, I should say, is to cross out any opposites. Because as we know, opposites cancel, right? If I have a positive 1 and a negative 1, well, what do I get? If I move forward 1 and back 1, I get back to 0. They cancel each other out. So we cross out any opposites to represent them canceling. After we do that, whatever counters are left over, model our answer. Whew, a lot of steps, 5 steps, quite a bit of writing. I'm going to give you about 30 seconds to finish writing, and then we're actually going to start with the process. So while you're finishing your writing, I'm actually off to the side going to write an expression. All right. So my first expression is 3 plus negative 5. So what I'm going to do is I'm first going to choose my counters. For positives, so this is step 1, I'm going to do green because I can, and I think it looks, I like colors. I think it makes it pop. And for my negatives, I'm going to choose red. Awesome. So then what I do is I'm going to look at my first integer in my expression and model it in a row using my counters. Now, what I like to do as well is I like to circle them based on their positive or negative association. So the first integer in my expression is positive 3. So I'm going to box it in green because I know that it should be green integer counter since it's positive. For instance, then my second integer is negative 5. Well, since it's negative, I'm going to box it in red because I should represent with negatives. So that's just another trick to help you make sure that you have the right colors. But now let's go to our second step. My first integer in my expression is positive 3, so I'm going to choose a row and make 3 neat integers. Right? Each little dot represents 1, and if I have 3 of them, that's 3 positives. That accurately represents positive 3. Okay. Now my third step, is to look at our second integer and model it in the row underneath. So again, my second integer is -5. So I'm going to go underneath and I'm going to put them in red. And I'm going to align them perfectly. Well, I have 1 negative, 2 negative, 3 negative, 4 negative, 5 negative. So I have 5 negatives. This graphic now appropriately models 3 plus -5. Now, what's our fourth step? We cross out any opposites. So in this case, a positive and negative cancel out, or a red and a green. Well, I see a red and a green here. It's gone. A red and a green here. It's gone because they cancel at 0. A red and a green here. That's gone. So then what does that mean is left over? Well, what I have left over is 2 reds. So what is my final answer to this expression? -2. So what this is saying is 3 plus -5 is -2. All right, we're going to do 3 more examples, but we're going to go much, much quicker now. So, example A. 5 plus 1. Now this one should seem pretty simple to us, but we're going to show how integers help us solve this, integer counters. So again, just for every single thing, my positives, I'm actually going to put it right at the top just so I know my positives are always going to be green circles and my negatives are always going to be red circles. It's up at the top. I'm going to use them for every example here on out. All right, now I'm going to look at my expression and I'm going to outline my numbers based on their positive or negative association. It's +5, so I know I have green, plus 1, that's +1, so I have more green. So what do I do now? I take my first integer, +5, and represent it in a row. That's 1, 2, 3, 4, 5. Then I take my second integer, +1, and put it in the second row. 1. Now I look for any cancellations. The biggest mistake people do is that they think that this right here, these two, cancel. But are they positive and negative? The answer is no. They don't cancel. Just because they're stacked doesn't mean they have to cancel. If we notice, they're both green. So they don't cancel at all because there's 2 positives. 2 positives don't cancel each other out. Well, what does that mean then? That means everything that we drew is left over. There was no cancel, so everything that we drew is left over. Well, how many positives is that then? That's 1, 2, 3, 4, 5, 6 positives. So what is my final answer to 5 plus 1? +6. Again, the main takeaway is only positive and negatives cancel. So you have to look at your color combinations. That's example A. Example B. This is getting big, but we're going to do -12 plus 15. -12 plus 15. -12 is negative, so I'm going to associate it with red. 15 is positive, so green. And then I'm going to create my rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can start seeing now that as the numbers get bigger, this process gets longer. Doesn't mean it doesn't work, but this is why we're going to start learning rules in class to make this a little bit shorter. Let's just make sure I have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. Now I align 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15. Notice again, it's neat. It's not dots just everywhere. It's really important that we're neat in integer counters or else it gets lost. Now I look to see if any cancel. So I look for opposite symbols. Yes, I see some red and green. Cancel. cancel, 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 cancel. Whew. In fact, 12 of them canceled. So what's left over? 3 positives. So what's my final answer? Positive 3. Awesome. Last problem. Example C. All right, I have -1 plus -7, so I have -1 and -7. All right, my first integer, -1, then -7, 1, 2, 3, 4, 5, 6, 7. Again, I look to see if there's any cancel. In this case, no, these do not cancel. Why don't they cancel? They're both red. So what does that mean our answer is? Our answer is everything we wrote down. That's 1, 2, 3, 4, 5, 6, 7, 8 negatives or -8. So that's how we use integer counters. If you're following along like I am, what you'll notice is there's only cancellations when the integers are opposite signs. What that means is one has to be positive and one has to be negative. If they're both negative, I didn't have a cancellation. They were just more negatives. If they were both positive, I didn't have a cancellation. They were just more positives. However, if one was positive and one was negative, that's when I canceled. So that is why it's really important to know your color combinations. All right, you'll have some practice problems after this video that you can check in your folder. Thank you.